What's up, everyone, and welcome back to Summarized Science. Imagine a robot that's incredibly smart but has slow reflexes, making it clumsy in the real world. This has been a major challenge for advanced robotics, where huge AI models are often too slow for dynamic tasks. This paper, running VLAs at real-time speed, presents a breakthrough in solving that exact problem. The researchers focused on massive AI models called Vision Language Action Models, or VLAs, which can see the world and understand commands. Normally, running one of these models takes a long time, but through a series of optimizations, they achieved a massive speedup. This table shows their incredible progress. The standard implementation took over 100 milliseconds to process information from 2 cameras. After their work, they slashed that time down to just 27.3 milliseconds. That's fast enough to process every single frame from a 30 frames per second video stream, a critical milestone for real-time control. This chart gives a great visual of where those performance gains came from. First, they removed bottlenecks between the computer's processor and the graphics card. Then, they simplified the AI's internal calculations to make it more efficient. Finally, they fine-tuned the low-level code that runs on the GPU to squeeze out every last drop of performance. To prove their system worked, they set up a real-world test. A robot arm had to catch a falling pen. This task requires a reaction time of less than 200 milliseconds, which is on par with an average human. The result was a perfect 100% success rate, showing these huge AI models can finally operate with human-like speed. But the researchers didn't stop there. They proposed an even more advanced framework for future robots called full streaming inference. The core idea is to have different parts of the robot's AI brain running at different speeds, much like our own nervous system. This diagram shows the concept, with multiple control loops working together. There would be a visual loop running at 30 times per second to process what the robot sees. At the same time, an ultra-fast force loop could run at 480 times per second, handling immediate feedback from touch or force sensors. Finally, a slower loop would handle complex reasoning and language, allowing the robot to think and plan without slowing down its physical actions. So, let's quickly recap the important points. Researchers have made a massive robot AI model run in real time on a consumer graphics card. They proved its effectiveness with a robot that can catch a falling pen as fast as a human. This work closes the gap between the incredible intelligence of large AI models and the speed required for real-world tasks. In the future, this could lead to robots that are not only smart, but also incredibly agile and responsive, able to work alongside us in fast-paced environments. Thanks for watching Summarized Science, and we'll see you in the next one.